So here we have a problem where we have a pole that is holding a flag, and that pole is sustained to the ground with two cables. They are giving us the force that are developed in each of the cables, and they want us to find the resultant force of these two forces. So we have a force right here. This is the force Fa, so we know the magnitude of that force. And we have a force right here developed in this cable right here. That is this force right here. So they are giving us the magnitudes of each of the forces, and they want us to find the resultant force in vector form, which will be AB plus FAC, and they want us also to find the magnitude and the directions cosine vector, which is the angles that resultant force formed with this axis. Okay, so the first thing that we will do is express these forces in terms of its components. We have the magnitude of these forces, and we have the direction in the sense that we have where it begins and where it ends. To start with this force AB as a vector, we know the magnitude of that vector that is given, that is 560. But we have to multiply that by the direction. You remember that anything that is a vector has two components, magnitude and direction. To multiply by direction, I will multiply by the unit vector, and I will make a difference between a unit vector and a vector with a little hat. That unit vector that only describes direction. So the magnitude of that vector is 1, and it only describes direction. How do I find this unit vector? This unit vector will be the vector between AB divided by the magnitude of that vector, so that I cancel the magnitude and only leave the direction. So what is this vector AB? There are several ways to find that vector. One way is to find the coordinates of point B, that will be RB and RA, and AB will be RB minus RA. So you can find the coordinates of these 2 points and find these vectors. Another way to do it is just do it graphically. When I mean graphically, what it means. So I go just cover the distance. So I'm going to go -6 in K. I'm going to go -3 in Y. And I'm going to go +2 in I. That's another way to do it. So I just went, it's like going in a highway or going in a little road. So I went this way. A, I cover K, I cover J, and I cover I. So I found this component. Now I have to find the magnitude. Remember that the magnitude of a vector is the square root of its components. So it will be 2 squared plus 3 squared plus 6 squared. That's equals to 4 plus 9 plus 36, which is equals to 49, which is equals to 7. So finally, this unit vector is equals to 2 divided by the magnitude in I minus 3 divided by the magnitude minus 6 divided by magnitude in K. So now that I have this unit vector and I have the magnitude that is given, I finally can find this force right here. Will be equals to 560 multiplied by 2, 7 in I, minus 3, 7 in J, minus 6, 7 in K. And that already gives me the following vector. 160I minus 240 j minus 480k. And it's very important not to forget the units. Let me squeeze here the units. This is in newtons. So I was able to find my first vector. Which is this one right here. Let's do exactly the same for the second vector. I'm going to use another color, so let's find this one right here, and I'm going to do the same. FAC will be equals to the magnitude times the unit vector. Very similar to find the unit vector. I will go, either I subtract RC minus RA, or I go following the path. So I will go negative K, 6, positive 2 in Y, and positive 3 in I. So this is my vector right here. So I went this way, and this way. And I have to find the magnitude of that vector. Sorry, this is AC. Let me correct that. This is AC. Because what I'm doing is that I am finding AC over the magnitude. So I just found the vector. The magnitude will be equals to 3 squared plus 2 squared plus 6 squared, which is 9 plus 4 plus 36, which is 49. Which is equals to 7. So therefore, my unit vector is equals to 3 over 7 in I plus 2 over 7 in J minus 6 over 7 in K. Now that I have the unit vector and the magnitude is given, then I can find that FAC is equals to this magnitude times this vector that I just found. And that leads me to the second force, which I will write the name. Well, this is so easy because 7 over 7, this is 300, right? So 300 in I plus 200 in J minus 600 in K. And the units of these vectors are in newtons. So I was able to find the second vector. Remember that this is a vector. Let's be rigorous with the notation. This is a vector. Okay, now that I have the two vectors, I can find the resultant force, which is adding the two vectors. Okay, let's do that. So I'm going to do it right here that I have a little bit of space. My resultant force will be AB plus AC, and I will add each of these components. As you see, 160 plus 300 is 460, right? So that will be equals to 460 in I. Then I have negative 240 plus 200, it must be negative 40. And then I have 400, these two add together for negative 1080 in K. This is the magnet, this is the vector, this is a vector quantity. They want us to find the magnitude and the direction as well. So what do we do to find the magnitude? You recall that the magnitude of a vector is each component square root of that. Let's do that. So the magnitude will be the square root of 460 square plus 40 square. I don't have to include the signs because I am squaring anyway. And that gives me a value of 1174 0.6 newtons. This is the magnitude. This is a scalar. Remember, this is a vector, and this is a scalar. So this has 3 components, and this is just 1 component. This is just a magnitude. How do we find the directions of this vector respect to x, y, and z? So as you see, this has this vector over here. If we draw this vector, is in I is positive, in j is negative, and in k is negative. So this is a vector that it goes something like that. We want to find the directions of this vector with the x-axis, with the y-axis, right? Which will be this one right here, and with the z-axis. So how do we find those? Well, recall that that will be alpha, which is the cosine of the component in x divided by the magnitude. That will be then equals to 460 divided by 1074.6. And that gives me that alpha is equals to 66.9 degrees. Beta is cosine to the negative 1 of the force divided by the magnitude. So the component in y, which is 40, divided by the magnitude. And beta gives me a value of 92. And finally, gamma, which is the cosine of the z component over the magnitude of the whole vector. I'm writing here at the end of the board. I'm sorry, it's a little bit squeezing it, the values. This is 50. Okay, perfect. So notice that whenever I have a negative value of the component, the angle gives me a value greater than 90 because it's in the negative side of the axis. So those are the 3 values of the angles that will allow me to construct the cosine vector. So these are the values of the angles that are between the resultant force and my axis. This is the parallel to x-axis, this is the parallel to y-axis, and this. So this will be alpha, this will be beta, and this over here will be gamma. And this is the solution of this problem.